Hi everyone, this is the second part of my video about the SaberRD, voltage controlled current source. So this is a GUI of SaberRD. So in the model, we access a different model and then simulate. We have a different part in the simulation part. We can do the AC analysis, frequency, DC analysis experiment. So I will use this experiment today. Let's go to the circuit. So we have a VGA microcontroller. This creates the enable signal. So the comparator is missing here. So let's add the comparator first. So it's very easy. You can double click and you can connect the comparator here. So now in the comparator, so you can modify the P offset. Let's put the P offset 2.5. But regarding to the what happened inside the comparator, so if I right click, this is the HDL language. So the beauty of HDL language that you can describe the hardware language. So I mean comparator is a hardware. So like if you look at the comparator, so we have enabled and we have VIN. So if VIN above the VH or VL, so or enable changes, so there is something happening in the comparator, then the output changes based on this input. So you can see this line shows that okay, wait on enable or VIN above VH or VIN above VL changes. So then after that we have something on if loop, then we can define the behavior of comparator. If you have any question about the HDL language, so you can send an email to me. I will describe in detail. So let's go, let's save the model. I want to run the simulation for this. So if I go to the transient analysis, you can see I have I can set the end and the step time, and also if I click this one, I access a lot of variables. So I can say okay, show all variables here, for instance, and so let's do the simulation first. If I run the simulation with 100 millisecond with the step of 2 microsecond. So if I run the simulation, so if I look at this is the input signal and this is the enable. So if I drag the enable here, you can see and just put a little bit thicker width for enable. So this is the digital signal. So you can change the enable, like this is the stream. You can you can add I can remove this one. So you can add or remove any point. So for instance, you can see from 0 to 40 milliseconds high, 40 to 80 milliseconds low, and 80 millisecond to 100 millisecond is high, and after 100 millisecond is low to 120. So now let's go back to the graph. So you can see for the 100 millisecond we have this pulse, and this is our input. So now we can check the other output. So let's look at the output of comparator. So in D, the output of our comparator. So if I double click on the in D, so it's on the digital side. So you can see this is the output of our comparator. So enable is high, works based on the like VL and VH. So here enable is low, so the V out enable is low, the V out is low, and then again continue. So for the next part we have AND gate. So we have delay for high to low or low to high. So if I looked at the the output of AND gate, so the output of AND gate is I source control. So let's go and find the output of AND gate. So this is output of AND gate. You can see the waveform and output of AND gate. And then if I check the D2 var, so this convert the digital signal to a unitless analog signal. So if I select the, you can see this signal is on the analog section. So if I double click, and then also if I double click again on the source, I can add the sensors here, and you can see how we build an analog signal from digital. So now let's look at the load. If we double click on the load, which is on the analog section, and then if we double click also on dB out, so you can see how like when the analog signal is from low to high, how we have a charging and how we have a discharging, charging, discharging. So we can easily track the signals with SaberRD. Yeah, so this is the protection part. So if the voltage goes beyond 3.2 volts, so then you know, the output of this gate goes to 0, and then the output of AND goes 0, and then we have just discharging here. So great.